All right, let's check your work and see how you did. So this is what I came up with for this first graph. I noticed that the arrow keeps going on and on that way. So x, I can be everything from negative infinity up to 3, including 3. So I'd write that in set builder notation as x is less than or equal to 3. With the y's, it goes up, 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 up. So I just need to be greater than or equal to negative 2. That's how you'd write that in set builder notation. Now for this next one in interval notation, we are just going to be between these values here. So the domain is between negative 4 and 3. We're not including the negative 4. Sorry, this should be a bracket here for the 3. And then for the range, we went from negative 5, not including the negative 5, up to 2, but including the 2. That's how you'd write that in interval notation. And then lastly, for number 6, we went x has to be greater than or equal to negative 4, and y has to be greater than or equal to 0. So that's how you find domain and range from a graph. Now, what if we aren't given a graph? What if we're just given an equation? How do we determine the domain without a graph? Well, to do this, I like to make an analogy about a microwave. Most people have a microwave, and most people have put something in a microwave that they shouldn't have. Have you ever done that? Maybe you could comment in the comments below. What did you put in the microwave that you shouldn't have? I've put in silverware like a fork, and I wasn't supposed to. Or I had there's this special type of plate that was china and it had metal built into it, and that was in there. So what happened when you put in the thing you weren't supposed to have? When I put in the metal, it started sparking and sizzling, and I was able to stop it pretty quick, but what would have happened if it kept going? It could have gotten ugly there. So there's certain things, microwaves are great. They make our lives really convenient, but there's certain things you shouldn't put in them or else it causes problems. The same is going to be with functions. Functions are great, and functions are like machines, like a microwave. And there's all sorts of things that we can plug into them, but there are two things that we should never do with our functions. Number one, and these are things that make our functions become undefined. So that's why we never do that, because it makes our functions become undefined. Number one is we never want to divide by 0. Never divide by 0. We already went through some examples like with that USS Yorktown, I think it was, that it stopped, it got shut down because it divided by 0 in its programming. Don't do that. The second thing we're going to avoid doing is never take the square root of a negative. Never, and I'm sorry, I have such bad handwriting, guys. Never take the square root of a negative. I'm just going to write it like that. All right. So what we're going to do is when we're looking at an equation, we want to figure out the domain. We're going to say, I can plug any values into this as long as it doesn't make me take the square root of a negative or divide by 0. Now, I should add in there, I shouldn't take any eventh root of a negative. So I couldn't do a 4th root either, or a 6th root or an 8th root, but the most common is square root. So let's just do an easy example. Let's say f of x is x squared minus 1. Is there anything I could plug in for a value of x, that would make me divide by 0, any number? Well, the denominator here is 1, right? So no matter what I plug into x, it's in the numerator, so would it make me divide by 0? So I'm good. That one's checked. I can plug in anything. Will I plug in anything that would make me take the square root of a negative? Nope. So then both of these are checked. So my domain is going to be all real numbers. I can plug in any real number and it will make sure that I don't, and this function will not divide by 0, and it will not take the square root of a negative. Now, in college, I learned that you can write all real numbers with a fancy R like that. You can also just put negative infinity to positive infinity. Okay, great. So now let's look at these next ones. Okay. f of x. Over here, I have x over x minus 2. So I need to look at that and say, is there any value of x that would make me divide by 0? And sure enough, x is in the denominator. So what I'm going to do is I'm going to focus on just the denominator. And I'm going to say, hey, x minus 2, I don't want you to be 0. You cannot be 0. So then I want to solve for x and say, what value of x would give me 0 in the bottom? And that would be 2, because 2 minus 2 is 0. So then I would write that as my domain. My domain is I can have x can be anything except for 2. Now, sometimes people jump to the numerator and be like, well, what about 0? Well, that if I plug in 0, I get 0. And 0 is fine. I don't care if it's 0. I just don't want it to be undefined. So to write the domain in set builder notation, we put our brace, and then we just say, x, you can't be 2. Now to write it in interval notation, it's a little trickier. We're going to start, it's basically negative infinity to positive infinity except for 2. So how do we exclude 2? Well, I'm going to go from negative infinity to 2 non-inclusive, and then I'm going to jump over 2 and go to right after 2, and then go on to infinity. That's how we'd write everything but 2 in interval notation. All right, so that's an example of how you would find the domain for something, for a rational function. Now let's look at g of x. I have a square root. The square root is in the numerator, so I don't have to worry about dividing by 0, but I do need to worry about square roots of negatives. So what I'm going to do is I'm going to take that part under the square root, it's called the radicand, and say you need to be greater than or equal to 0. And it's okay for it to be equal to 0, because when it's equal to 0, square root of 0 is 0, so you're fine. So I'm going to rewrite that. So I'm going to say 2 minus x, you need to be greater than or equal to 0. And then I'm just going to get x alone. Probably the easiest way to do that is just add x on both sides. So I get 2 is greater than or equal to x. Or x is less than or equal to 2. They mean the same thing. Just remember, if you switch the side of x, you switch the sign. So to put that into set builder notation, I'm just going to look like that. I'm going to put that line a little bigger. All right. Now, this is saying x needs to be less than or equal to 2. So to put this in interval notation, less than or equal to 2, we're going to the left. So that would go all the way to negative infinity and up to 2 inclusive. You could check that. Just plug in some of these numbers in here. For example, plug in 2, I get square root of 0. Plug in 1, I get the square root of 1. Plug in 0, I get square root of 2. I just don't want to get negatives. All right, so last but not least, let's look at h of x here. I've got two things. I've got a denominator here, so I'm going to say that denominator, you can't be 0. And then I've also got a radicand, so I'm going to say you need to be greater than or equal to 0. So let's split that up. I get 2x plus 1, you can't be 0. And then over here, I'm going to say x plus 1, you need to be greater than or equal to 0. Then I'm just going to solve. From here, I'll subtract 1, and then divide by 2, and I get x cannot equal negative 1/2. If I plugged in negative 1/2, it would give me 0 in the bottom. That's not okay. Then over here, I get x needs to be greater than or equal to negative 1. So I've got two things going on here. X has to be greater than or equal to negative 1, but x can't be negative 1/2. Now, to help you visualize this, I'm going to draw a number line. Here's our number line. Here's negative 2, negative 1, 0, 1, 2. Okay. Now, our first thing says that x needs to be greater than or equal to negative 1. So that would be right here. We want to be greater than or equal to negative 1. So which direction is that? That is to the right. So I want to be all of these values, except I can't be negative 1/2. Negative 1/2 is right here. So at negative 1/2, I'm actually going to have to come in and like take out this little piece right here. Oh, I meant to just erase a little bit, but whatever. We're going to have to put a little hole in there and say, okay, I want to be everything except for everything that's greater than or equal to negative 1, except for negative 1/2. I'm just going to write this one in interval notation because basically if I did it in set builder notation, I would just put both of those together. To do this in interval notation, look, there's an interval right here, and then there's another interval right there, and I just need to join those together. Negative 1 is inclusive, so I'm going to go from negative 1 to negative 1/2, but not include negative 1/2. That's this first part. The second part here is going to be that negative 1/2 all the way to infinity, and we're just going to join those together. And that would be how you do the domain if you have both of them. All right, so that is your lesson. So I hope that makes sense with how to get domain from a function and domain and range and what is a function, what is not. If you have questions, feel free to email me. Good luck, and I hope to see you soon.